Very good morning to students. Today we are going to discuss about the in part of the mine environmental engineering subject, particularly the booster fans, where you are required to enhancing the our pressure and quantity. Location of neutral points of booster fans is required. So it is a one view of the mine, and also this is a image of underground mine, various places for quantity surveying purpose conducted. That image I am here given. Well, today the subject is concerned by environmental engineering. In part, the auxiliary ventilation system, the booster fans. We are going to discuss it. Already, we are already covered some air ductings, 4A4, forced and exhaust systems. These things already covered. The part in the booster fan system, we are going to today. Explanation is going on. On completion of this topic, would you would able to necessity of booster fans and in underground mines? Explain the terms of the booster fans you are going to study this one. So already in the previous class we discussed the auxiliary ventilation system, the condition required for auxiliary ventilation system, different methods of arranging auxiliary ventilation, precautions in installing auxiliary fans, single heating system, auxiliary ventilations for double heating. So, from what is the mean by booster? A booster is the one which boosts up or increasing the activity of anything. So that is the name itself is showing that boosting. So it will be uh, further from existing without any effect of main fan pressure. They will simply promoting one to other. That is a main criteria of the booster. Booster is a sometime used for ventilation in certain districts. They increase in quantity by increasing the pressure, causing flow, and size of the booster fan can be calculated for the any quantity depending upon the requirement. Any quantity can be enhancing and increasing in the quantity in the booster district, increasing the total quantity passes through the mine, which result in greater pressure losses in the shaft and the trunk airway, those reducing the pressure across the splits. Basic definitions. What mean by necessity of the booster fan installations in mine galleries? When the quantity of air is less in one or more districts of high resistance for in by in the deep mines and hot mines, it is required to increase the quantity of air supply. When there is a excessive leakage between intakes and returns, when there is a excessive leakages, when the and there is excessive leakages between the intakes and the returns. Coal mines which are liable for spontaneous heating, coal mines which are liable to spontaneous heating. As the name suggests, booster fans are those installed underground for boosting up or supplementing the air circulated by the main fan. They may be assist the surface fan for ventilating the whole mine when they act in series within the surface fan, but such installations are rare since it is always better from the point of view of capital cost and efficiency to choose a single fan. So this is one suggestions for the booster fan installation in the underground. So this is a very cute figure. Where to installations? That is also very important. By seeing, you can understand. In this regulation, all unless the context of otherwise require means a mechanical ventilator. A booster fan is nothing but a mechanical ventilator used below ground for boosting the whole current of air passing along the intake or return airway of mine or ventilating districts. So means a mechanical ventilator used below ground for boosting the whole current of air passing along the intake or return area of mine ventilating districts. So that is the basic concept of the booster fan. Is a definition is concerned as per the mind regulation. So here is a location is showing the booster fan location. This is the auxiliary fan location. Can be compared. What is the mean by auxiliary and a booster fan? Go through this figure. Very clearly mentioned here. Then the fan, when circulating large quantity, generates less pressure. The reduction of the quantity circulating through the unboosted subdistricts to large booster is one split can cause stoppage of air current or even reversal of air current in other splits, particularly if the trunk resistance is high compared to the resistance of the split. That is why it is essential to have an judicious choice of size of the booster fan. Position of the booster fans also need careful consideration, particularly in leaky airways. So that is also you have to consider where the locate booster fan without affecting other things. So this is, you can hope that basic idea is it is a only just like mechanical ventilator for boost to whole current or the part of return or ventilation districts. A booster fan is a more or less a permanent installation. Booster fan is a more or less a permanent installation. The fan is a larger dimension and used for augmenting ventilation of when individual splits or districts not adequately ventilated. A booster fan is a more or less permanent installation. The fan larger dimensions and used for individual splits of districts not adequately ventilated. Booster fan is used when the desired increase of airflow cannot achieved economically. Either uh, in an underground mine, sometimes ventilation will be insufficient. Some districts are part of the mine. In such situation, ventilation can be improved by means of auxiliary ventilation. Auxiliary ventilation is possible by means of auxiliary fan and booster fan. The location of booster fan and the auxiliary fan important to improve the ventilation. The condition required the use of the booster fan. The booster fan may be used for the one or other of the following purpose to increase the quantity of air in one or more districts of high resistance for NBI, to improve working conditions in a deep hot mines by speeding up the air and increasing its cooling power, to reduce the excessive leakage between the intake and return that would occur if the surface fan was speeded up to give the increased quantity, to reduce or adjust the pressure difference between the intake or return in mines liable to spontaneous heating. So these are the reasons to establishment of the booster fan is concerned. Once again, I read it. Conditions required to use of the booster fans. Number one condition is booster fan may be used for one another of the following. To increase the quantity of air, that is the main purpose. In more districts, high resistance will be there. To improve the working conditions, to in deep hot mines by splitting of air, increasing its cooling power. To reduce the excessive linkage between intake and return that would occur if the surface fan was speeded up to the give increased quantity. To reduce or adjust the pressure difference between intake and return of the mine liable to spontaneous heating. So these are the factors considered for location of the uh, booster fans. Then we come to the what are the factors to be considered for location of booster fans. The best position for a booster fan is in a proximity of the neutral line. This is a very important. The neutral line is concerned. The fan is placed too far in by of the neutral line, the recirculation would occur. Also, if the fan is placed too far out uh, by the neutral line, a pressure difference is produced between the intake and return, and excessive leakage occurs. The effects of existing ventilation system, particularly on the seal of GOF, should be studied. If the ventilation airway are located along the seal of GOF, the isolation stopping should be strengthened. So it is a one example showing the booster fan, just like a large underground fan which installed a series with the main fan to boosted the pressure is showing in the underground mine. Well, uh, the use of booster fan underground handle only the a portion of the total air circulated to supplement. The primary fan is a phase of auxiliary ventilation, properly termed booster fan ventilation. There is a basic definition. Uh, Booster fan have me widely employed in non-coal mines. However, the trend of mine regulation legislation towards bringing non-coal mining regulation closer to those for coal mining, thereby precluding the installation of my main or booster fan underground where permitted. Booster fan may be used effectively on a high resistance split to reduce the overall pressure drop across a parallel circuit that the primary fan must overcome. There are three ways in which desired quantity of air may be distributed to branches of a parallel circuits having unequal pressure drop across the branches. Controlling splitting using regulators in the low resistance splits. To balance the circuit, controlling splitting using a booster fans, high resistance splits to create a balance. Free splitting achievement in decreasing of the number of airway balance pressure drops on the basis of economical operating costs. They are listed in order to increase in performance. So generalized, you're using when the booster fan is installed. So these are the uh, main criteria to be considered for this purpose. See, this is a location of the booster fan. Can we elaborate it here somewhat for easy understanding purpose? There is a working place is one side here. This is a doors, which is a regular air is going, but the booster fan is installed here. So it is a speed up the pressurized working places by installing the booster fan. Please go through this simplified sketch how to locating booster fan at a particular location. By this figure, you can easily understand. Right. So now already an underground fan installation in the main air stream to handle the quantity of air circulating through a section installed in a permanent bulkhead and equipped with a set of airlock doors and fan monitors. Fan monitors. A proper sized and sighted booster fan can be used to create a safer working conditions and allow the extraction of the minerals from great depths. A properly sized and sighted booster fan can be used to create a safer working conditions and allow the extraction of the minerals from the great depths. So this is a major criteria. Booster fan in underground coal mines. Sample of coal mine ventilated by exhaust system of ventilation has one long wall section and two continuous minor section as one main surface fan as one main intake and two smaller intake airways has a good scope of the use of the booster fans. So the sample of the coal booster fan in underground coal mines can be ventilated by exhaust system of ventilation as one long wall section and two continuous one section as one main surface fan can be sufficient has one main intake and two smaller intake airways has a good scope for the use of booster fans. So this is the main advantages concern. Now this is a booster fan. Another further details given here. Purpose of booster fans for improving the working environment in a case of deep and hot mines through improved air velocity, for improving the working environment in the case of deep and hot mines through improved air velocity, for increasing the air quantity in a particular district panel, booster fans can be used for increasing the air quantity uh, in a particular district, for increasing in air quantity in a particular district panel. Booster fans can be used. The disadvantage of booster fans sometimes installation of the booster fans in one district may be reduced the flow of air in another district. The purpose of booster fan, this is the main for improving the working environment in a case of deep and hot mines through improved air velocity. For increasing the air quantity in a particular district, a panel booster fans can be used. Disadvantage of booster fans are sometimes installation of booster fans in one district maybe reduce the flow of air in another district. So that is a other disadvantages of that one. Sometimes installation of booster fan in one district may reduce the flow of an air in another district. That is a basic disadvantage of the booster fan. Basic purpose is this one, but sometimes it may maybe get the disadvantages to reduce the flow of air in other districts. So it will suck automatically. You can be understand by seeing this figure, seeing that if air is going this right way, if dropping from where to you dropping from where you to going other section, it's taken away. So booster fan installation, it will be sucked to the other, just like a straw. If any there's two straws in one bottle, that's a very coke or something persons are any you see in movies or market also. You are provided the two straws. For example, if you suck the more, what happened? The other person will not get it if unable to suck. So similarly, that example can be quoted here. The booster is boosting some, it is sucking more quantity to this side because it's a need to purpose serve some problems and where you are identified. But at the same time, other section will be affected. So that should be justified. The location of the booster fan is very important, right? Right. This is a complete. So schematic of the booster fan model given here. There is a intake main fan. So it is a boost fan is given. So gases sources are there. So some written regulators also there. Is showing there. Please go through the simplified figure for the understanding various elements of the ventilation network. And one more network I am showing here. Different type of ventilation symbols as well as the directions, how intake and airway going on. Various elements, auxiliary booster fans, locations, very clearly showing here from the hoist shaft, this intake shaft to the return shaft, primary shaft. So it can be see observed here. This is intake. The blue color is showing. So the air is entering to the different headings. So red is showing the return, which is contaminated air and also as well as uh, carrier of all the things. That road is different is showing here. This high symbols is on the booster fans location. These are the booster fan. This is the booster fan. These are the booster fan. These are booster fan locations are showing here. And development of the fan also given. Districts fans also showing here. Intake and return were blind end also showing districts. So these are the symbols, standardized symbols for the ventilation network is concerned. Please go through it. And then fan and environmental monitoring system is showing here. There is a the one color is showing tube, Monde, methane, and also delta pressures. This is where the intake is coming and return is going on. This is one model of fan and environmental monitor system for understanding purpose. See how to intake airway going and also coming to the other monitoring cells. So return verify collecting. The booster fan also located that is also can be double bypass door system. This can be identified here. And then this is also generalized networking system of booster fan is concerned. So here booster fan is the location is there. This is the air crossing, the working area. Return. This is the regulator. This is intake in the doors, the upcast and the downcast. Stoppings. Stopping is the intake is there. Main fan, booster fan is there. So this is called as a uh, main regulator system. Right, booster fan, return airway intake is there. Air locking doors, bulkhead, return fan system. So intake and there is a return bulkhead doors. This is one other model to location of the booster fan 2 by 2 booster fan system to speed up activity in return. See, observe when it is located in a return airway. And then DA mill colliery ventilation. So this is one foreign country ventilation colliery. Booster fans are located in the return and motor are the enclosed in a flame-proof housing because of the risk of spontaneous combustion. Booster fans were installed in a rock above the coal seam. Booster fans are sited in by the current neutral ventilation points to there is a small amount of air recirculation, less than 10%. Booster fans are essential to provide adequate air volume and control heat. The fans increases the volume of air at the long wall face by 50%. This is one of the major thing. A booster fan in an underground mine, sometimes ventilations will be insufficient. In some districts, the part of the mines in such situation, ventilation can be improved by means of an auxiliary ventilation. The auxiliary ventilation is possible by use of auxiliary fan and booster fan. The location of booster fan and auxiliary fan important to improve the ventilation. So this is the one neutral line system where the booster fan is exact location, how it's affecting for fan F1 and F2 or two alternative position of the booster fan. The location is showing here very clearly. Phase served as intake and return airway separate from each other by leaking barrier. It will show that depending upon the amount of leakage, the pressure drop from the entrance intake and phase, and again from the phase to the uh, outlet of the return will be the form above figure showing. Simplicity of you assuming the straight line pressure gradient between the entrance of the intake or outlet of the return and phase to the assumption approximately true for the small leakages. Uh, you see that here 35 mm of the pressure is dropped here. There is a pressure, 50 mm pressure. So this is one better example for the neutral line. That means location of the fan is located of somewhere as another switch. How the pressure is dropping. The figure is showing that. So how exhaust fan will affecting for one split. Regulator split is there. Neutral point, that is the location of the point of the booster. So regulator split be affecting, open split is affecting. Regulatory pressure, this is called as the pressure. So total overall fan pressure. The how because of the neutral point location of booster fan cause the affecting other areas. So this is a booster fan 0 to 5, 10, 15, and 20. The pressures are given neutral point and pressures 1.66 kilopascals is already given here. Plus 0, 5, 10, 15, 20, minus 600, minus 1600, minus 2600 neutral point distance in meter. And then main fan, neutral point, booster fan, total pressure drop, static pressure in districts. So this is also one model for the understanding for the how the dropping because of the booster fan is caused. Nine. The booster fan, as I already discussed, it installed it into increasing the quantity of air passing in a split or ventilating districts of high resistance. Such splits may be either in a long single split or one in parallel with another split. When the fan is installed, the water gauge on the return side of the split, booster fan as already discussed, installed, increasing quantity of air passing in the split or ventilated districts of high resistance. Such splits may be either long single split or one parallel with another split. When the fan is installed, the water gauge on the return side of the splits also automatically uh, coincide. At least one some distance, increasing in relation to the on the intake side of, and there is some position in the ventilation system of the split, where after the installation of the booster fan, there is no pressure drop between the intake and return. Such position known as the neutral line, that is called, and shown in the LL in the figure. So most of the above figures are showing NL. So that is the location of the exactly where the point, there is no pressure drop between the intake and return wave. That is called the neutral line. That point is location is very important. In above points, you can observe what is the neutral line. This is a neutral line where the pressure is not dropping in the intake and airway. And here, this is a neutral line where the person not flowing. Here, this is a neutral point. So these are the point where the pressure drop not happening. So that is a basic idea of the neutral line is concerned. The best position for a booster fan in the proximity of the neutral line. If the fan is placed too far out by of the neutral line, the recirculation would occur. If the fan is placed too far out by the neutral line, the pressure difference is produced between the intake and the return, and excessive leakage occurs. In underground mine, sometimes ventilation will be sufficient. Districts of mine, such situation can be improved by the main axial ventilation. So this is the basic idea, of course. What are the effects of installation of booster fans? What are you expecting? What are the impacts due to the booster fan is concerned? Some advantages, some disadvantages also there. Um, what are they? What are there? You can see here. The effect of installation of booster fans are, the immediate effect is fall in the resistance. The fall in resistance. And then the effect, the effect, the immediate effect of the um, within the main fan has worked, so that if the fan is pressure is constant, increasing volume of the airflow through the mine. If the resistance of all area remain uh, constant, there is an uh, increased pressure drop in trunk airways, so that the pressure difference between the intake and return at the point of split get reduced, and a smaller quantity of air passes in splits other than on one with which fan is installed. That is also been observed. If the booster fan pressure is considerably high, all the pressures to the main fan may be lost in the trunk airway. Within the result that no air flows through splits other than one in which the fan is placed. The booster produces a pressure higher than this reversal of air may be taken place. The highest pressure that the booster fan can produce without air reversal take place. It is called as a critical pressure. That pressure is called as the highest pressure that the booster fan can produce without air reversal take place is called, it is a critical, it's called as a critical pressure. The highest pressure, that is the booster fan, can be produced without any air reversal take place. It's called the critical pressure. That is pressure is very important to show it. These are the effects of booster fan is concerned. And then another one is showing here. If the booster fan pressure is considerably high, all the pressure to the main fan may be lost in trunk airway. Within the result that no airflow through splits other than one in which the fan is placed. If the booster fan produces a pressure higher than this, reversal of the air may take place. The highest pressure uh, that booster fan can be produced without air reversal take place is called the critical pressure. That is a major things. So now these are the major things you can observe here as regarding the booster fan is concerned. Uh, the booster fans are largely underground fans that can be increasing volume volumetric efficiency of ventilation system by balancing the pressures and quantity distribution throughout the mine, reducing leakage and reducing the total power requirement. Booster fans prohibited in underground coal mines in the United States. That is very important. Some countries are prohibited due to recirculations of fan or efficient such plants. These things. Booster fans are large underground fans that can be increase the volumetric efficiency of alimentation by balancing pressure and quantity distribution throughout the mine, reducing leakage and reduce the total power requirement. Booster fans are prohibited in underground in some countries, like United States, other countries. Now we are going to concluding almost. So far, you learned about the definition of booster fan location installations. Regarding on this, we had getting there some type of questions that is regarding uh, for getting in examination point of view. Those questions you can observe here. Effect of installation of booster fans. These are observed. What are the effects of installation of booster fans? The surface fan getting overloaded, fall in the resistance, no change in the metal system, rise in the resistance. These are the general effects of due to booster fans cause because you are the put into in middle of the air, but you're not taking you from where to take correct the air means the affecting of the surface fan getting overloaded, fall in resistance. So it is the one effective. No change in the metal system. There is no changes in the metal system. Rise in resistance. Resistance will be raised as much as there is one other advantage. There is a no. There is a no. There is a no pressure drop. There is a no pressure drop between the intake and the return. Such positions known as semi-temporary line, neutral line, permanent line, parallel line. There is a no pressure drop between the intake and return. And such a position is known as generally it's called as a neutral line. Second is answer is correct. Neutral pressure drop, which is where there is no falling of intake and return. Such location is called the neutral line. A booster fan may be used to stop the quantity of air to increase in the quantity of air, to decrease the quantity of air, all the above, which is correct. To stop the quantity of air, not correct. To increase the quantity, all. So sometime we have to most of the B is correct. That is the two is second answer is correct. To increase the quantity of air is our prime motto. Then, if the fan is placed too far in by the neutral line, what happened? Semi-temporary, the recirculation now would occur. No change occurs. The presence difference is produced. So this is the answer you have to tell after thorough of your question. And then another question is there the necessity of booster fans in underground mines to deep mines to hot mines quantity air is less all the above. So it will be applicable to the which mines? Most of the in deep mines, not in hot mines. That means not hot mines you cannot be put a deep. So deep mines we have a recirculation of air is concerned is important. And the booster fan is more or less a semi-temporary installation temperature. This is already given here. This is a not is a only the semi-temporary installations. Sometimes it can be continue or not, depending upon situation is concerned. So with this we are going to concluding the about the booster fans. So I hope you were enjoyed today lesson, but particularly this topic is concerned. I hope that you are getting more what is the necessity of the booster fans in uh, underground mines and it is terminology and installations. I hope that you are understanding well in these things. I wish you all the best. Thank you. Thank you very much.